We want to prove that the difference between the squares of two consecutive odd numbers is divisible by 4. Let's consider some examples. 3 squared take away 1 squared is 9 take 1, which is 8. That's equal to 4 times 2, so it's divisible by 4. Note that 3 and 1 are consecutive odd numbers. We could do 5 squared take away 3 squared. That gives us 25 take away 9, which is 16, which is 4 times 4. Once again, divisible by 4. But of course, to prove, we need to use algebra. Take a positive integer n. If we double it, we get an even integer. Adding 1 gives us an odd integer. The next odd integer would be 2n plus 3. Consider 3, 4 and 5. 3 and 5 are consecutive odd integers. We get from 3 to 5 by adding 2. We've done the same with 2n plus 1 and 2n plus 3. We want the difference between the squares of these two numbers. So we want 2n plus 3 squared take away 2n plus 1 squared. Expanding the brackets by any method, 2n plus 3 all squared is 4n squared plus 12n plus 9. Take away, and we need this in a bracket, 4n squared plus 4n plus 1. Expanding the bracket now, we have the 4n squared plus 12n plus 9. Take away 4n squared, take away 4n, take away 1. 4n squareds cancel, 12n take 4n is 8n, and 9 take away 1 is 8. We have a common factor of 8, open bracket, n plus 1. We know that n plus 1 is an integer, since n was an integer. It follows that 8 times n plus 1 is divisible by 4. Further, it's actually divisible by 8. So we've shown that the difference between the squares of two consecutive odd numbers is divisible by 8. But being divisible by 8 also means it's divisible by 4.